And welcome, ladies and gents, to the 6th lesson from Chapter 9A. Today we're focused on graphs, still proportional relationships, but today we'll focus on representing those graphically. Go ahead and pause, check your answers, come on back when you're ready. And so, folks, where we've been, where we're at now, and where we're going, where we've been, we've just decided, okay, is it proportional? Is there a constant ratio? We call that the constant of proportionality. If it is proportional, we can write an equation. So we should be able to look at a table or a relationship of any sort and decide, is it proportional? What would the equation look like? Today is going to be similar, but instead of being given a table, we're going to be given a graph. We're going to decide if it's proportional. And if it is proportional, we're going to find that constant of proportionality and we're going to write an equation for it. Now, sooner or later, we will get to relationships that may not be proportional and how to write equations and use equations like that. But for now, we're sticking to proportional stuff. All right, if I could invite you, please, to head to your Google Classroom or just follow along with notes. I'll be going over notes again in class. And before I start doing these notes, there's something at the bottom. I don't know if I put it at the bottom of my screen. I didn't put it there. My bad. I want to, it might be at the bottom of your notes. It says something about how can you tell, what do you notice about the graphs of relationships that are proportional versus the graphs of relationships that are not proportional? What do you notice? So I want you to keep that in mind. I'm just going to plant that seed with you as I continue into number 1. Now, first things first, directions say A, determine if it is proportional. B, graph each point, connecting with a straight line. And then we got the proportional, yes or no. If it is, what is the constant of proportionality and what is the equation? First thing we're going to do, though, is we're just going to determine, is it proportional? Remember, we're always going Y versus X, like dollars per hour, miles per gallon. If I were to set up these relationships, notice here, 4 to 2, 6 to 3, 8 to 4, 10 to 5, 12 to 6. Is it proportional? You betcha. The constant of proportionality is 2. Now, it doesn't give us any units, so we can't say dollars per hour, miles per gallon. Yes, you could write that as 2 to 1. Yes, you could write that. Another way of writing a ratio is with the colon, 2 to 1. So there's a number of ways. Most of us will just write 2. What is the equation? I'm going to actually skip straight to the equation and write y equals 2 for every 1x. Then it says use the points. So let's go ahead and take these points. 2 is my x value, 4 is my y value. Then I go to 3, 6, and then I go, whoop, my bad. Let's put this over here, shall we? Then I go to 4 is listed as 8, and 5 is listed as 10, and 6 is listed as 12. And I'm going to go ahead and I'm going to draw a line through those points as straight as I possibly can. Come on, line, where are you at? There we go. And we'll go all the way to the y-axis as the directions point out, connecting all the dots. And so here is the relationship that A, we've determined, yes, it is proportional. B, why is that? Because the ratio is always 2 to 1. That's the constant of proportionality. We've written an equation for it, y is equal to 2x. And then we've looked at the graph, plotting the points, and then drawing a line that connects all the points. Now remember, as we go through this, you're looking at the graphs of the things that are proportional versus things that are not. All right, let's go ahead into this. And number 2, once again, I'm going to start setting up some ratios. But I see pretty quickly something's up. This is even 3 1/3. This is 3 wholes. This would be 2 4/5. Is it proportional? That's a big old no. Therefore, there is no constant of proportionality, and there is no equation yet, at least in this period of pre-algebra, that we can write. Now we're going to go ahead and we're going to graph the points. The first point, x is 1 and y equals 6. Then I follow my line axis, x equals 2, y equals 8. For the next relationship, when x equals 3, y was equal to 10. For the next relationship, when x equals 4, y equals 12. And the rest goes off the graph, and that's okay. So I'm going to go ahead and I'm going to once again select the line. And if I am very careful about drawing this, that didn't work. I thought I had the line selected, so I guess I will just draw it with my pen. Connecting this, you guys probably going to need a ruler, a straight edge. You're welcome to use your ID. So now, is it proportional? No. Why? Because there is no constant of proportionality. Therefore, we cannot write a proportional equation. We've graphed the points, and we've connected the dots with a line, or should I say a ray, that goes all the way through the y-axis. In fact, right about there is where it might start. So I wonder if you're already looking at the two graphs. How are they similar? How are they different? Let's carry on to example 3, please. 2, 3, 4 to 6. Again, make sure you're always doing rise versus run, y versus x, 6 versus 9, 8 versus 12. No, 8 to 12 reduces, 6 to 9 reduces, 4 to 6 reduces, 2 to 3 doesn't. But guess what? Is this proportional? Big old yes. Why? Because it constantly has a unit rate of 2 to 3, 2/3. We can take that and write our equation. And now we're going to graph out the points when x equals 3, y equals 2. When x equals 6, y equals 4. When x equals 9, y equals 6. And when x was 12, 12 was related to 8. Now I'm going to see if I can get this to work again. Try to draw this with as straight of a line as possible. Hey, it worked this time. How about that? Now you're welcome to look back at number 1 and 2 and 3. How is number 3 similar to them? How are they different? What do the graphs look like? And if you want to alter your prediction or your observation, please do so. Remember all along, what do graphs look like that are proportional, and how are they different from graphs of relationships that are not proportional? Onward we go to number 4. Whoops, still have the arrows. Let's get rid of those, shall we? And I'm going to write the relationship 1 versus 3 and 2 versus 4, and so on. Now 4 to 6, that's interesting, 2/3. I mean, we could go a step further and put them all in decimal form to the nearest hundredths, but I think you see immediately that something is fishy. Is this a proportional relationship? No. Why? Because there is no constant ratio here. It's not like we can say $4 per hour or $5 per hour or $6 per hour. Now let's go ahead, use these points. Shoot, I have the red dot frozen. Oh well. When x is 3, y is 1. When x is 4, y is 2. When x is 5, y is 3. And 6 to 4. I guess I could draw a line through these. But I'm supposed to go all the way to the y-axis, which is down there. I guess it hits right there. All right. Continuing to look at these relationships. Actually, I can't remember. Is that on the back side or the front side? That is on the back side. Okay, so I'm not going to tell you right now how to fill in the blanks. The graph of, so look at the very bottom of your page. The graph, what do you notice about the graphs of the proportional relationships? The graph of a proportional relationship is a blank blank that passes through the blank. I'm not going to say it. Come to class, we'll talk. Onward we go to number 5. Cost of running a video game is shown in the table. First part, determine if it's proportional. Explain your reasoning. So here we go. Now remember, y to x. The cost depends on the number of games. So the cost is the dependent variable. 5 to 2, 7 to 3, 9 to 4. 3, 250. Oi. This one is like, a repeating decimal, and this is 2 1/4. No. And if we were to graph these points, hopefully you made the observation, what does a graph look like? Because honestly, if you would have graphed the dots first and then drawn the line, you should have been able to see if this looks like a proportional relationship or a non-proportional relationship. Moving right along. Now notice this is the slowest mammal, not the slowest animal in the animal kingdom. 6 feet per minute. Determine if it's proportional by graphing and then explain your reasoning. So I'm not going to go straight to the ratios. I'm going to go ahead and graph 0, 0, 1, 6, and so on. If I were to draw a straight line through it all, making sure my line goes through the y-axis, boom. So, is it? Yeah. Constant of proportionality. Well, Mr. Cowan, they already said 6 feet per 1 minute, and I should have written that with the units. Write your equation, y equals 6x. Again, you should have spotted that right away when you look at the graph. Onward we go. Oh, is that it? Yeah, that was all. How about that? So, homework, assignment number 8. Make sure to write assignment number 8 at the top. You should be able to identify immediately looking at the graph, is it proportional or not? And of course, if it's not, then you write NA, not applicable, or just write an X, because there is no constant. If it is, you are expected to find that constant as well as to write an equation. All right, folks, that's what I got. I look forward to seeing you tomorrow. Have a great day, and let's grow.